Have you ever wondered if there's a master plan for life on Earth? A hidden set of rules that connects something as simple as a single blade of grass to the entire human population? Well, the answer is a surprising yes. And together, we're going to uncover these fundamental principles that shape every single living thing on our planet.
So, what are these universal rules? In this explainer, we're going to dig into how nature actually builds itself from the ground up. We'll look at how it maintains this incredibly delicate balance. And this is the big one. What happens when one species, that's us, seems to be playing by a completely different rule book?
At the heart of it all is this idea of environmental equilibrium. You can think of it like a delicate dance between every living thing and the physical world around it. This intricate balance is what allows life to flourish. But as we're starting to see, it's a balance that's becoming more and more fragile.
To really get a grip on that balance, we first have to see how life is organized. It's not just some random jumble of creatures out there. It's actually a perfectly structured ladder, scaling from the tiniest individual all the way up to the entire globe.
So, let's climb that ladder together. We're going to zoom out, starting with just a single organism, and move step by step through 5 distinct levels. By the end, you'll see the entire living planet as one massive, cohesive system.
All right, starting at the very bottom rung, we have the individual. It's as simple as it sounds, just one single organism. Could be a coconut plant, a fish, or, like you see here, a single elephant. This is the basic building block for everything else.
Okay, let's zoom out one level. Now we have a population. This is a group of the same species, all living together in the same area. For instance, back in 2011, a census counted the elephants in Sri Lanka's Yala National Park. The number was 5,879. That specific number, at that specific time, was the park's elephant population.
So what's the next level up? The community. And this is where it gets really interesting. Because it's not just one species anymore, it's about all the different populations interacting with each other. So back in Yala, it's not just the elephants. It's the leopards they avoid, the deer they compete with for food, the insects they stir up when they walk. They're all connected.
But wait, that living community doesn't just exist in a bubble, right? The next level out is the ecosystem, which brings in the whole non-living environment. Think about a pond. The ecosystem isn't just the fish and the frogs. It's also the water itself, the mud at the bottom, and the sunlight that gives everything energy. It's the whole shebang.
And finally, we get to the ultimate zoom out, the biosphere. This is it, the sum of every single ecosystem on Earth. It's the thin layer of our planet where life exists, combining the land, the oceans, and the air. This is the grand stage where all these rules of life play out.
Okay, so now we understand the structure, this organizational ladder, but how do these populations actually work? I mean, what makes them grow or shrink? Let's dive into the natural dynamics that control the size of any given population.
It really boils down to just 4 simple things. A population gets bigger through births and immigration, that's new individuals being born or moving in, and it gets smaller through deaths and emigration, individuals dying or moving out. It's a constant push and pull.
Now, when you track this balancing act over time, a really clear and predictable pattern shows up for most populations in nature. It's called the sigmoid curve, or, way more simply, the S-shaped curve. Let's break down its 4 phases.
So, first up is the lag phase. When a new population is just getting started, growth is really slow. It's kind of like trying to get a cold engine to start. There might not be many individuals to reproduce, or they're just too spread out. It takes a little time to get going. But then, if conditions are right, we're talking tons of food, no predators, the population hits the exponential phase. And this is the boom time. Birth rates just totally crush death rates, and the population explodes. It's growing at its absolute fastest rate possible.
Of course, that explosion can't last forever. Eventually, reality kicks in. This is the deceleration phase. Resources start getting tight, there's more competition for food and space, and diseases might start to spread more easily. The environment starts to push back, and the growth rate slows way down.
And finally, the population enters the stationary phase. This is where things level off. The number of births and the number of deaths are pretty much equal. The population has reached a kind of dynamic equilibrium with its environment. It's not that growth has stopped, but it has stabilized.
That stable plateau illustrates one of the most important ideas in all of ecology: carrying capacity.
It's the maximum population size that a particular environment can support, day in and day out, without collapsing. You can think of it as nature's ultimate speed limit.
So, we've seen nature's elegant S-shaped curve and its built-in limits, but what about us? This brings us to our final and, honestly, most dramatic section, the very unique, very strange path of human population growth.
I mean, just look at the difference. It's night and day. On the left, you've got that stable, predictable S-curve that everything else in nature follows. And on the right, that's us, a nearly vertical J-shape. We haven't leveled off. We are still deep in that explosive exponential phase, blowing right past the limits that hold back every other species.
So why are we the big exception? Well, it really comes down to 3 game changers. Our technological revolution, which lets us literally reshape our environment, our medical revolution, which sent death rates plummeting, and our agricultural revolution, which lets us produce food on a scale that's just mind-boggling.
To really feel the insane speed of this change, let's just look at the numbers. It took our species, Homo sapiens, about 300,000 years to reach a population of 1 billion people. Think about that. Pretty much all of human history to get to that first billion.
Now, get ready for this. How long did the second billion take? Only 130 years. What took us 300,000 years to do the first time, we did again in just over a century. The acceleration is just staggering. And it gets even faster. The jump from 2 billion people to 4 billion took only 15 years. 15! What took 300,000 years and then 130 years, we recently did in less time than it takes to grow from a toddler to a high school graduate. That's the power of exponential growth.
And this brings us right back to the beginning. We've seen that every other population on Earth is governed by a carrying capacity, a hard limit set by its environment. Our J-shaped curve suggests we've somehow broken that rule. And that leaves us with the most important question of all. Nature has its limits. Do we?